have next up here Dan Gunter. He is speaking to us as the founder and CEO of Insane Forensics. So that's an industrial-focused forensic automation software company, helping asset owners detect, respond, and recover from threats to operational environments quickly and safely. Before Insane Forensics, Dan served as Director, Research and Development for Dragos, an industrial control system cybersecurity firm, and served in the United States Air Force. Dan earned a Bachelor of Science in Computer Science from Baylor University, a Master of Science in Computer Science from the University of Louisville, and a graduate certificate in Incident Response from SANS Technology Institute. Dan has spoken at RSA, Black Hat, DEF CON, ShmooCon, S4, and, the mouthful, CS3STHLM, is that correct? And he taught at private events on the topics of incident response, threat hunting, consequence analysis, and security operations. So we should have plenty of experience here from Dan on planes, trains, and plant maintenance networks.
And do you have the clicker by chance? Okay, awesome. Thanks for the intro again. My name's Dan Gunter. What we're going to talk about today is kind of a fun area. If you haven't explored this is totally an area you should go home and explore if you're an asset owner. If you have, I'm sure you know there's a lot of fun out there when it comes into how plants are maintained and what those networks look like. So awesome. Thank you so much. So today, what we're going to talk about what maintenance networks look like. We're going to unpack what they are, where they are, some of the misconceptions and realities we hear. We're going to then talk through how you can assess these, how you can look at what is actually going on. We're going to talk about doing it with open source tools. So again, you can take hopefully what you learn here and do it without any more investment in anything else. But we'll talk about where to look, interpreting results, and then finally we'll talk about securing these networks. So what are they, right? These plant maintenance networks, especially now in today's world, if you don't think data is going up to the cloud and you're like a GE or other customer, there's a whole ton of data now that OEMs are taking that OEMs are involved with this. This is used for everything from monitoring, diagnostic, predictive maintenance. We'll talk a lot on a few use cases on theirs, but there are very real-time reasons that these maintenance networks exist. And for the productivity of a lot of industrial environments today, they actually rely on these links. And so these are not links you can just say, hey, let's disconnect, let's try to isolate, let's send things backwards. We're kind of past that point. That ship has sailed, if you will. Common examples you'll hear, and today we can't call anyone out. We have to watch actually what we share because OEMs often don't like you talking about their maintenance networks for risk. And so we will not call anyone specifically out. But some examples of one out here you'll hear in industry is like GE's monitoring and diagnostic, the Atlanta Data Highway. Or if you're in Houston, Baker Hughes, right? They have their equivalent. The difference is if you're in energy, it actually goes to Atlanta. If you're Baker Hughes land, it goes over to Italy, goes over some other way. Fun fact, if you're in Saudi Arabia, it actually goes to Dammam. We'll talk to some of that. But even that's an interesting thing because when it comes to these monitoring and diagnostic networks, there's actually some differences depending on the part of the world you're in on how they operate. Siemens has Sensei. We'll have a really good case study for that on what that means. But we talk about the impact on operations. We talk about their importance. When we look at this, so Siemens Sensei, this is at every Nissan plant, auto plant across the globe. And what Nissan does with this is actually saving them just a ton of maintenance downtime. And there's some numbers off to the left. We're talking millions of dollars a year saved through predictive maintenance on the plant, right? And so, again, running efficient operations, how they do it is through these plant maintenance networks. We'll dig into how they do that in a minute. Another big one for GE when you look at Exelon, and so Exelon uses the maintenance network a lot for wind turbines to kind of hit that peak. Hey, here's historically where wind's at. Here's how we can actually operate our turbines, operate our things out there. And this is actually from a case study from GE. They'll actually model the real wind values, the baselines, the old models, and look at that to get their wind farm running as efficiently as possible. To do this, and you'll see this commonly, this isn't just a G thing, you'll actually see it across other OEMs also. In the case of the wind farm, what they have is, right off of the historian that's collecting all that operational data, there's a Predix machine actually out at the plant. All of that data gets sucked up into AWS, into G's area of AWS, to where they're doing all kinds of analytics, see things like Logstash and Kibana and Postgres and a bunch of databases up there. Funny enough, like 2 decades ago, all of that was actually 4 Oracle servers. And so G's actually expanded out over the decades as they've connected more things together to where now you see more common fields. To give an idea, when you talk about GE, just about every GE service generation plant is actually on the maintenance highway. So when you think about the size of this network, it's a massive, massive network connecting these plants. When we talked about, that wind efficiency and all that, they're actually getting a feed for weather, right? So they're taking in weather feeds to do all of that awesome predictive math up there. But again, when we talk about these maintenance highways, a lot of times you'll see this reference architecture. And when you actually go out into the field into a plant and look at this, you'll actually see bits of this. And so even if you're looking at this link right here, there's a lot you can see inside the plant of how you're actually interacting out with that. And we'll talk about that through the walkthrough area. For Exelon and G Predix, some of the wins here is they're generating about $2 million more a year of revenue from being efficient here, right? So again, with the math, with all of that predictive stuff they're able to do, they have this rolled out to dozens of wind farms. And so when you talk impact on operations, you're talking millions of dollars again in additional capture. Last example I'll use, because we talked title, we tried to bring in a few industries. Southwest Airlines. So Southwest Airlines is a big GE Predix user. And what Southwest is doing with it is they're like, hey, there's a sweet spot for how much fuel you put in the plane to get it to be just right so you can make it, right? And if you're an airline, you're weighing, how much fuel do we need? How many passengers do we have? What's our cargo weights? What's weather and nav data? The G data highway is actually sucking in all of those things to get to that right fuel load. When you talk about their impact on operations on this, 1% in fuel load over 15 years is $30 billion. And so again, operationally, these aren't networks you can necessarily avoid, and these are key parts of not just how do you save money on fuel costs, how do you keep your planes in the air, how do you make sure, hey, this plane needs maintenance, let's do it before it breaks and it's a big disruption. So how do these operate, right? And again, we'll use G speak a little bit. The other ones have other things. Generally, what you have is data paths that go all the way down to the turbine, right? So if you're in G land, you can go all the way down to the Mark controller and say, hey, if you're on the plant side, if you're in this sector, at some point there's a control system, right? On site, oftentimes you'll see the OEMs have their firewalls, so they're doing some level of filtering generally at the plant, saying, hey, let this function code through, don't let this function code through. Oftentimes, those firewalls often have things like, hey, let's go into maintenance mode, because in maintenance mode, we might allow a different class of operations than we allow in normal time. Again, that's still on site. It goes through a firewall. Eventually, there's an edge gateway. Oftentimes, what you have before it goes up into the cloud is you'll have a VPN encryptor. And in the case of some of the OEMs, that encryptor actually goes up into cloud space that you can't necessarily hit from the internet. You can't hit some of the IP spaces, luckily, that's back-end monitoring and diagnostics. Once you go up into the cloud, they have a whole host of systems. We'll share some stories later on that. But the big thing to note on this is how this actually looks. It does vary by vendor, and there's a whole lot of different risk that can be introduced. On some plants, some OEMs actually have domain controllers up in the cloud part, and your box down here in the plant is actually a part of a domain controller up in the higher area. So when you talk about assessing risk in this plant, you might actually have domain-joined boxes in your plant that are joined to your OEM's network. So all of the things you have to worry about with Windows endpoints, it's key to understand this. But How these work, again, there's no magic to it. It works the same way in the plant, it works the same way out, but there's a lot of stuff you can dig in through as you go through this. Again, there's often multiple layers of filtering. We've had projects to where we've watched like maintenance windows, what OEMs have done in the plant. We had cases to where an OEM overstayed their maintenance window, and then we were building a time series of, okay, this was what was going on as they were reaching in the plant to do the maintenance. Interesting thing with some of that is actually a lot of the turbines have debug mode, so you can actually put turbines into debug mode remotely and do very granular control oftentimes over these. And so, again, there's a whole lot going on here. We mentioned earlier, regional differences do exist. And so if you're in North America versus Saudi Arabia versus other places, sometimes where stuff goes, the data that routes, government regulations vary place by place. So that was kind of an overview of what some of the maintenance networks look like. What we hear today when we're out in the field, a really big misconception in reality is this is a one-way link, right? People, a lot of places are convinced there's somehow a data diode, and we're like, well, maybe there's a data diode, but there's data diodes in both directions, so really it's a bidirectional data diode going on here. The truth is, again, and for a lot of them, they haven't actually pulled a PCAP and said, this is actually what's leaving the plant. To where if you pull it, then you have some really hard conversations of being like, hey, you're using TCP, right? Yeah. Well, how are you doing the three-way handshake if this is a one-way connection? And then they're like, oh yeah, that's a good point. So in a lot of ways, we still go out to plants to where they think these data diodes, they think these maintenance links are one way. They haven't been in most cases. Oftentimes you do have some ability to control when they can and can't key in, but they're not. Thing to look at, I mentioned remote turbine debugging, I mentioned other things. When we're assessing a lot of sites to see, okay, how two ways is this, we look for some of those operational things like, okay, you're telling me that remote engineers can help me with my turbine. How exactly are they doing that? And by walking through that exercise, you often kind of begin to see, wait, this isn't just a one-way link. There's actually a lot you can do. Second one, plant-based maintenance assets add minimum risk. Again, as I was saying, some of the OEMs domain join boxes into your plants to their domain controller. We've seen PowerShell Empire go over domain, over maintenance highways. We've seen all kinds of bad Windows domain practices going over there, right? So something that we point out here is it's important to understand how your OEM is actually managing those boxes. Something I will say with some of the OEMs that we've worked with on this, we've asked and we've been like, hey, we know you're managing this box in the plant. Can we just get some of the Windows event logs off of it, right? Can we get some data from this? Will you give us some granularity into this black box that's in my plant that you're communicating with? I will say a lot of the OEMs have been receptive to that. Sometimes you have to have the right account manager, sometimes you have to ask more, but it's a key thing to do as you go through there. This is a fun one. So remember, on these maintenance highways, you have to remember also that these OEMs oftentimes have thousands of plants that they're connected with across the world. They often have different tools that they're using to maintain boxes, different tools they're using to do their different operations in the plant. And so this misconception in reality of, oh, it's just going to be an OT protocol, it's going to be filtered down to the minimum deal. What we found when we pulled traffic from a lot of plants and looked at it, there's oftentimes a lot of risky things to where you really need to get into, okay, what is going through this? What is going through this HTTP message, right? How are you actually doing endpoint management? We often see, and this was before all the SolarWinds stuff, there's actually OEMs that are using SolarWinds on their managed devices inside the plant, right? And people didn't know that before the whole SolarWinds stuff. They didn't know back either, but it's really key to understand, like, not just the protocols and everything going on, but what they're actually doing about it and what their firewalls are actually filtering off of it, right? Last one, we mentioned it, and then we'll move on to the next point of this. You'll actually call us when you have security alerts. While we were looking at the maintenance highway of one of the vendors, we got access to one of the endpoints in the plant that they manage. We looked at the AV logs and we're like, oh, there's PowerShell Empire in here from 2 years ago. So we called them and we were like, hey, you didn't call us about PowerShell Empire going over 2 years ago, right? And they're like, oh yeah, we didn't call you. And so remembering that again, even though they might have McAfee, so a lot of them are using McAfee antivirus, we're now seeing some OEMs push CrowdStrike Falcon and some other EDRs out into the plant. You really want to jump on them a bit and be like, okay, are you actually going to call us if you see alerts? Because again, these are your managed assets, but they're in my environment, right? So again, it's key to push for this. The importance of this assessment is, again, these networks are still very misunderstood. One of the things we do often when we go on sites is we ask them, we're like, hey, when's the last time you actually looked at this at your last hop before you jump out into these OEM networks? Most groups now stare at us. They're like, maybe we have a passive network monitoring solution looking at it, you know, but we often haven't. Oftentimes we see they haven't looked a lot there. Because understanding how they work, you actually can begin to apply even basic security controls. Some of the OEMs, their management tools actually use just HTTP traffic to communicate up from the OEM down to the plant. And so watching how their maintenance links work, you actually can bring down some of the risk of the software and hardware that they've introduced into the environment. So there are quick wins once you understand that. The way to actually do this, what we recommend is starting with a site walk down, right? First of all, identifying what OEMs are actually having management into your plant. Second of all, fun story here, trace the wires in the cabinet. And so oftentimes we'll go into the plant. The last one that we went out and saw, we opened up the cabinet, we saw the firewall that the OEM was managing. The management port of the firewall was plugged in external to the plant because the OEM views the plant actually as outside of their firewall, right? They view themselves as kind of the key part. And so understanding things like, okay, in your plant on this, the management port of that edge firewall going up is actually on the OEM side, right? Knowing where wires are actually tracing, where they can actually go to, that's kind of opened up interesting things as we've gone out there. OEMs do have protected best practice guides. Oftentimes these are NDA, these are under protection, sometimes to where you have to ask for them, you have to be a customer. There are some good guides out there to where some of the manufacturers are being a little more open, both on this is what's actually going on, and here are best practices for it. So talk to your OEM, they're doing better jobs at getting some of this information out there. Make sure you capture, make and model stuff out there, and then identify your network and host capture points. So again, oftentimes if you're like in G's land, you have the Atlanta data highway portion to where often you have the excitation controllers, you have what's called the OSMs, on-site management boxes, which are kind of their first hops out and in. You generally have an engineering workstation that controls, and then you have a few other sections to that management network, like the plant data highway, the unit data highway. They're different subnets. When it comes down into this network and host data capture, you kind of want to consider the architecture of your plant, and then also see, hey, let's look for maybe groups jumping from this section to this section. Let's look for groups using this part of the box, right? And again, we've actually had success at asking OEMs for access to these managed boxes and them giving it to us if you ask nicely enough. Then what you can do, take that network traffic, take network traffic at that maintenance edge, take it from those sections, take the host data. What's interesting with host data, again, is if that OEM managed box is a Windows endpoint, well, you can pull the Windows event logs and say, okay, we know when people logged in, right? You can pull the application logs. The even more critical ones to pull are things like, okay, let's pull the engineering workstation logs. Let's pull some of the OT specific logs to say, what activities, what behaviors have we actually seen over this? Because again, in a lot of the plants we've been into, a lot of people don't have good visibility on what's going through there. If you're feeling fancy, definitely pull memory. We've had some interesting things also in disk image finds on there. What else? Configuration logs. So there's some OEMs, and we're not going to name which one, they actually put, they put like VPN services, OpenVPN and other stuff with default passwords that they use at every plant. And so looking for things like that, like configs to where if you're a red teamer, it's really awesome because once you break into one OEM's plant, it's really easy to break into other plants when they reuse passwords everywhere. For you as an asset owner, it's like, wait, yeah, this service exists, and some of the passwords I'll say are out on Baidu and other places, so actually some of the passwords are already known for some of the OEMs if you look. Consider the time when you capture too, right? Normal operations, maintenance windows, you're going to see different distributions of traffic. You'll most likely see different function codes coming through, different operations happening, but capturing at different times, it can help with that baselining when you're getting a lot lower. Data analysis, tools that we like to use. Just your off-the-shelf Zeek and T-Shark, there's a lot you can do in there. There's more OT protocol libraries coming out for those, both from DOE and other groups. I know Amazon dropped a lot out. Again, on this maintenance highway, though, they're using a lot of common IT protocols. So you look at DNS, you look at HTTP, you'll actually find some really interesting stuff on how a lot of the OEMs are doing business across these. You can also look for your effectiveness of network segmentation and filtering. This is something we recommend pushing because, again, you might get advertised to say, hey, this box is blocking all traffic except this, but you look in this in Zeek and T-Shark and you might say, hey, why am I actually seeing this traffic go through, right? This might be a good covert channel. Other big thing on this, map your internal and external ports to justification. A good way that we do for this is we'll take the manufacturer's guide for what they, like their firewall ports guide, and we'll say, okay, across this maintenance highway, we're seeing these historian ports that our assets are reaching out to, right? We're seeing these ports tied to these known OT services. Some of the vendors, they'll actually give you an Excel spreadsheet if you ask them nice enough, and they'll say like, hey, this port ties to this service. Sometimes they'll tell you it ties to this process. If not, it's important to build it yourself because then you can say, okay, when should I see someone remotely access my engineering workstation to push this logic out, right? You can begin to look for those behaviors. And it's important, again, to see what is critical across that link. So for host, again, what we recommend on that, EVTX out, volatility if you're doing memory, seeing what's actually running on that endpoint. I'll tell you some of the OEMs use very poorly written Java applications, some use poorly written .NET applications, others are using just really crazy configurations out there. So figuring out, if you're doing this from the host side, figuring out what those endpoints are actually running, what's actually running on the box, how are they remotely accessed? You can look kind of at the hardening. You can suggest the hardening. You can see what the OEM will let you harden. We've worked with asset owners that have actually pushed back on the OEM quite a bit to say, hey, how you're running this box in our plant isn't sufficient to our security needs, so we want to do these things. And they actually won. They were like, okay, yeah, we'll make those changes. In some cases, at one plant, they actually convinced the OEM. The OEM was like, okay, we'll give you access to it, but you're going to have to manage it now. And the plant actually ended up accepting management of that box just because the configuration of it mattered to that point. So again, what you're trying to do here is collect data to understand what's going on there and where there's risk. Again, look for password reuse because we see that a bit. On the reporting side, right, you want to really begin to draw a really good picture of how that works. I'll tell you, when you see some of the documentation on how these plant networks work, there often is a difference between the documentation and what you actually see in data. We've called this out to some OEMs and they've been like, oh yeah, Dan, you're right. It's not actually like it is in the documentation. You're actually right as you see it on there. And so documenting how it looks specifically in your environment is key because then you can get into controls, right? What existing controls do we have? What future controls do we have? How do we buy this right? Work with your OEMs to clarify findings. Again, this talk isn't to call anyone out. This isn't to say, if someone's doing a bad job. These are very complicated networks. Again, they support a whole lot of things. And I'll tell you that the OEMs that we've worked with, which unfortunately a lot of it's under NDA, They've been super, super helpful under NDA helping with this type of stuff. They actually are your friend at this phase because they want you to be successful and a happy paying customer. And so, let them be that chance for you, right? Feedback, make sure to leave, if you're on the cybersecurity team, make sure actually to work with the plant operations team, right? Make sure to work with the OEM. A lot of the insights here that you'll learn are really key, right? And you'll want to make sure your feedback actually has operational steps there. Why we put that there is you'll actually learn a ton from these people too, because while we might think in the cybersecurity aspect, oftentimes these teams have a different perspective, and so sometimes they'll be like, well, Dan, it runs this way, and then you can be like, oh yeah, that puts something I'm working on in context. Best practices, what it comes down to is it's hard to defend what you can't see, right? So the actionable path forward here, again, is going out, doing that site walk down, pulling data, figuring out what it looks like, figuring out at one plant, and then seeing what you can quickly roll out to multiple sites if you're dealing with a large enterprise, right? Digging deeper into those network comms, right? You have to go beyond that 5-tuple of just IP and port and protocol, right? And you have to dig deep into those network comms to say, hey, generally across these networks, there's a reason that these communications are occurring, right? There's a reason that this management tool exists to help this OEM manage these boxes, right? And so digging deep into your network comms is going to help you, especially if you have passive network monitoring in place, because then you can use some of the tools you might already have to look deeper at this. We've run into asset owners that are actually stronger on the host side. If you're stronger on the host side, the same thing applies over there. Understanding the applications and intents, this is key. Again, we've seen, so for some of the maintenance highways, how they manage stuff is they have an agent on the box. They can actually send remote commands directly to the command line of your engineering workstation software of every function in that engineering workstation software. And so again, when you're at the granularity of across this maintenance highway, you can do anything anyone sitting at that EWS can do. This gets you to that point of, okay, let's start to monitor. Let's start to see what's done. And let's then say, hey, if we're seeing a different type of service being performed, different type of work being done, we can kind of call them out on it or dig deeper, right? So again, understanding the behaviors is really key here. With that wraps up the talk. Again, this was kind of a quick dive on maintenance networks, why they're important, some of the stuff we saw. Because again, these maintenance networks, they're not going to go anywhere. They're incredibly important, hopefully, as you see. There is a lot of security risk with them, but there's also a ton we can do. So with that, any questions? Yep. Yeah. Yep. Yep. So balancing kind of the risk with the urgency type deal and doing it now? Yeah. Yep. Yeah, and some of this depends on culture. It depends on how proactively too, sometimes the IT or the side managing this potentially is with the others. To your point, where we've seen this, I'm thinking of one asset owner in the power sector that we've done this with. They're very proactive, and so one of the first plant maintenance projects that I was involved with, we went out to power generation and getting both sides engaged, getting not just the cybersecurity people, we actually had the plant manager engaged, we had a lot of the operations people engaged. They thought it was really cool because, hey, a cyber person's trying to learn how all of this works and is asking me, how the plant runs. And so it gives a chance for both sides to geek out. and build that camaraderie, I would say the biggest thing that immediately comes to mind is trying to build that camaraderie, right? Because oftentimes, to your point, it's often done in two different teams, and so getting people to just work together sometimes is the hardest, right? Yeah, question? Yeah, so the question is, why aren't more people talking about this? It's a great question. So what complicates some of this maintenance highway a bit more on some of the vendors is they have proprietary protocols that they don't like to talk about at all. They're starting to talk about them a little more. Some as the OEMs haven't appreciated necessarily this being talked about. Some is it's a hard problem, and going out, a lot of people honestly haven't looked there yet, or they haven't asked the question. They've just assumed well, they told me this was a one-way link. They just told me that, and so some has been people not checking assumptions, some has been just people not doing the homework. Any other thoughts? Ron, why haven't they done that? Yep, no excuse to ask the question. Mm-hmm. Yep. Some is too probably, when we buy some of the passive network monitoring products, regardless of what it is, we assume them to go to a certain depth. And a lot of these projects now are still delivered heavily via professional services. And so it's something too that there's a little bit of a gap right now between the depth, and some of the passive network tools are starting to get deeper into these data highways, but there's still a big delta between you're only going to get this insight with professional services versus there's a product that can actually get to this granularity. Yep. 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 Yeah, yeah. Awesome. Any other questions? Well, cool. Well, thanks for coming out, everyone. If you do have questions, please feel free to reach out, and thanks for stopping by today.